Is it discussed syllabus? Okay.
Yes, ma'am.
So we little bit class में syllabus টা নিয়ে discuss করব. Okay. So basically, physics 101 course is just there are 3 credit course and 3 part. First one is the Webster oscillation, second physical optics, and third one is the modern physics. Okay. So I will take 2 credits. Okay, I will take the optics part and also at the same time modern physics part. Okay? So for 2 credits, you will get in 2 weeks 2 class. Okay, 2 class. This is my first class with you. Okay, so so I think Webster oscillation lecture after we discuss because lecture after we will take your Webster oscillation part. So as I'll take the optics and modern physics part, so I'll discuss about this. Okay. One thing is that is at first I will start with the modern physics. Okay, I will start today. I have 2 classes with you. One is from the 9, okay, another one is from the 11. Okay, for Ramadan there is little bit change in the time. Okay, so I will check first. I will discuss about the optics syllabus. Okay. So in the optics part, okay, there are lots of chapter, 5-6 chapters there, but don't worry, the content inside the chapter is very less. Okay, it's less, but chapter is good. At first, in the optics part, there is lens. Okay, in the lens there are only 2 topics: what is equivalent lens and power. Okay, the next chapter is the defect of image. Okay, and in this chapter, defect of image, different type of revelation are discussed. Next is that third one is the interference of light. Interference of light, and here we learn about the Young's double slit experiment, interference, the field, neutron stream. Okay, interference, diffraction, polarization. These 3 are the big chapter. Okay, these 3 are the big chapter. So when we get question, that is the main part of the question you will get from either interference, diffraction, or polarization, and the smallest part from the other chapter. Okay, mix up question. Okay, like 2 chapter, 1 question, like this. So from diffraction part, that is diffraction of light, we get diffraction by single slit, diffraction by double slit. Okay, Fresnel and Fraunhofer, where it's a F. Okay, this is Fraunhofer and Fresnel. Okay, diffraction pattern in biprism, diffraction pattern. Okay,
ম্যাম সাউন্ডটা খুবই আনক্লিয়ার আসছে.
now polarization of light. Polarization of light. Mr. Law, Malus law for polarization of light. That is Mr. Law, Malus law. When polarization by double diffraction, nickel prism, then optical activity and polarity. Okay, and next one is that optical instrument. Optical instrument, only one topic is there, that is in optical. I think optical, what is optical instrument? Do you have any idea? Optical instrument, that is the instrument deals with the optics, that is the optical instrument. Anyone can give me the example? That is optical instrument, for example, anyone can give any example of optical instrument?
Glass, telescope, microscope.
Yes.
microscope,
Right. So what is your total estimate?
telescope,
তোমাদের total student কতজন?
around 100, ma'am.
Around 100.
100, ma'am, 93.
93. And optical instrument, and in this chapter, we discuss about the resolving power of optical instrument. Okay. Then next, last part, that is laser. Laser part. In laser part, we discuss about the spontaneous and stimulated emission. Okay. This is all about our optical. This is all about our optics. Okay. So it is basically 7 chapters here, but the content is very small. See, in the laser part only spontaneous and stimulated emission. Okay. And next is the modern physics. You can see modern physics. And again, we'll start from the modern physics. Okay, so we'll start from the modern physics, and today we will start the Bohr atomic model. Bohr atomic model. Then we'll calculate the radius of the orbit, the energy level of the orbit in our first class. Now we'll discuss about the Bohr atomic model. Then in the second class, if I get time, then I'll discuss about the photoelectric effect. And I will give the lecture sheet each and after every class. I will give you the lecture sheet. Now you can note your Google Classroom code. So, D part S E A N. I'm writing in your chat box. Okay. Chat box, your Google Classroom code. So this is your Google Classroom code. So after this class, you get the 2 lectures sheet there. Okay. Now we start our modern physics. So first thing is that what is called modern physics? What is called modern physics? Any idea? Modern physics control. Basically, 20th century আগে যত physics নিয়ে ডিসকাস হয়েছে, তত যত থিওরিজ আসছে, সব আর ইনক্লুডেড ইন দ্য ক্লাসিক্যাল physics. Okay, that is classical physics. But at the beginning of the 20th century থেকে যত physics এর laws এবং theories আবিষ্কৃত হয়েছে, মানে সব কিছুকে ধরা হয় হচ্ছে মডার্ন ফিজিক্স। তার মানে beginning of the 20th century তেই হচ্ছে আমাদের মডার্ন ফিজিক্স এর যাকে বলে মডার্ন ফিজিক্স এর জন্ম। Is that clear?
No, ma'am.
Beginning of the 20th century. 20th century আগে যেগুলো হচ্ছে সেগুলোকে ক্লাসিক্যাল ফিজিক্স এর আধারে নেওয়া হচ্ছে। It is just for a knowing purpose. What is modern physics? Modern, আধুনিক। Okay, modern physics. This starting from the beginning of the 20th century. ঠিক আছে? আচ্ছা, আমি তোমাদের Okay, so today we'll start with the Bohr atom model. You can see the picture of the board on the screen. Okay, Achha. Bohr atom model. What is the speciality of the Bohr atom model? When you read it in the HSC level, in the Bohr about Bohr atom model, can you tell 2 points or 1 point related with Bohr atom model? Which will be speciality type Bohr atom model?
স্পেকট্রাম ব্যাখ্যা করতে পারতো।
ওকে, আচ্ছা আমরা আরো বেসিক থেকে বলি যেমন এই বোর অ্যাটম মডেল কি বলেছিল, still that is the positively charged nucleus at the center, তাই না? Positively charged nucleus at the center and electrons, negatively charged electron move around the nucleus, তাই না? আচ্ছা, so আমরা Bohr atom model now we will learn about the postulates of the Bohr atom model. ঠিক আছে, এখানে there are 5 postulates are here, so I'll discuss these 5 postulates. Okay, so you can see on the screen that is the postulate number 1. Okay, an atom consists of positively charged nucleus at the center. Okay, the first postulate is that an atom consists of positively charged nucleus at the center. Here 2 things we are about to know. That is, one thing is that nucleus is positively charged and the location of the nucleus is at the center. Okay, so second one, this is our first postulate. Now go to second postulate. Then second postulate is that the negatively charged electron. Now we have to know that the electrons are negatively charged. We already know that before the Bohr atom model. The negatively charged electrons move around the nucleus in various orbits. Okay, so negatively charged electrons move around the nucleus in various orbits known as stationary energy level. এগুলোকে কি বলা হয়? Stationary energy level. It's orbit where the electrons are moving in the orbit, so these are known as the energy level, stationary energy level, like first energy level, second energy level, third energy level, like this. Today we learn about how to calculate the energy level. Okay, we'll derive this one. Okay, now go to our third point. Third point is that electrons are moving around the nucleus. Okay, keeping nucleus at the center, and electrons are moving around the nucleus. Okay, now we know that is, now think about one electron. One electron is moving around the nucleus. The nucleus is positively charged, electron is negatively charged. So nucleus will attract, isn't it? Attract the nucleus. Individually, it will attract all the electrons. Okay. So what will happen due to the attraction? Electron will collapse. Then electron, you can say this is the Coulomb force or electrostatic force, or you can say it is centripetal force, isn't it? So কি করা কথা? Electron কি collapse হয়ে যাওয়ার কথা না? What did you say? Collapse হওয়ার কথা? কিন্তু electron তো collapse করছে। কেন? Why? Electrons are moving around the orbit, okay? The orbit around the nucleus. It has some velocity, okay? Because of this velocity, okay, and the motion, it will feel or it creates the centrifugal force. Centrifugal force. তার মানে we get two force. One we get centripetal force and another we get centrifugal force. centripetal force, centrifugal force. These two forces are equal. Okay, that is why when electrons move in the orbit, it is stable condition. It's moving around the nucleus, but it's stable in that orbit. Okay, because centripetal force and centrifugal force are equal. Okay. Now, fourth one is that is the angular momentum for electron. Fourth one is the angular momentum for electron. Angular momentum is equal to mvr nh by 2 pi. So what is h? What is h? Who can take what is h?
Planck constant.
Yes, it is Planck's constant, but it is a fixed value. Can you tell what is the value of h? It is
6.626 into 10 inverse 34.
and unit.
Joule second.
Good. This number, this constant value will use in your bag. Okay, but in the question you will not get the constant value. You have to memorize or remember some value like Planck's constant, mass of the electrons. Electron mass কত বলো তো?
9.1 into 10 inverse 31 kg.
Good. Then charge of the electrons like this. আমি বলে দেবো কোন কোন এগুলো লাগবে আমরা ম্যাথ করার সময় দেখবো ওই আমাদের কনস্ট্যান্ট গুলোকে আমাদের মনে রাখতে হবে ফর অফ ম্যাথমেটিক্যাল প্রবলেম। এটা হচ্ছে তাহলে ফোর্থ নাম্বার 4 the angular momentum for electron mvr to nh by 2 pi. এখানে n is the integer number, h is the Planck's constant. Okay. Now last one, that is last postulate. You can see last postulate. Okay, last postulate is that when the electron from the outer orbit or higher orbit, electron in the higher orbit, it's jump to the lower orbit. Okay, higher orbit energy is more. The higher orbit energy is more. When it jumps from higher orbit to lower orbit, then it emits the extra energy in the form of electromagnetic radiation. In that case, the equation is that Wn2 is the energy in the higher level, level N2, and minus Wn1 is the energy in the lower level. Is subtraction of difference between these two energy levels is equal to h mu. It is not v, it is mu. Mu is the frequency. So difference in the energy level is equal to h. These are the 5 postulates. So first one is that postulate number 1, positively charged nucleus at the center. Number 2 is that negatively charged electron around the nucleus, okay, in the fixed orbit, known as the stationary energy level. Third one is that Coulombian force, okay, that is your centripetal force and centrifugal force are equal. Number 4 is that your angular momentum, that is mvr equal to nh by 2 pi. Equation that is mvr equal to nh by 2 pi. I will use in the calculation of the orbital radius. Okay. And last one is that when electron from the higher energy level jump to a lower energy level, it gives out electromagnetic radiation. Is that clear? These are the 5 postulates. Very simple, but frequently it comes in the exam, maybe in the CT or in the midterm. Okay, okay. So now I'll show you how we calculate the radius of the orbit. And we practice the math related with the rupees. This is your Google Classroom. Already I told one thing, that is in the electrons are stable in the orbit, okay? Because there is an electrostatic force working on it, and the centrifugal force working on it. These two forces are the equal force, okay? So we can start with that, okay? So we can start with that. That is, if electrostatic force is equal to centrifugal force, okay? Centrifugal force. Achha. Now we'll find out one expression for Fe and another expression for Fc. Then we'll equate these two, okay? Achha. Now what we can write for Fe? Fe, that is electrostatic force. Electrostatic force, what we can write? Coulomb force. Coulomb force টা কি বলতো? Constant একটা value আছে, constant একটা জিনিস, ওটা কি?
9 into 10 to the 9.
No, not in the numerical number.
1 by 4 pi epsilon naught.
Yes. That is 1 by 4 pi epsilon naught. That is a constant, is a proportional to constant. Now, divided by distance square, r square, okay? এখন উপরে কি হবে বলতো? থিটা চার্জ আমি কি লিখব?
ZE into E.
Good. That is ZE into E. এখন দেখো, that is ZE. What is ZE? ZE is the charge of the nucleus. Charge of the nucleus. What is it? Z. What is Z? Z is the atomic number. Atomic number means it is the number of photon. Number of photon. Right? And E is the charge. Yeah. Charge of the photon. So E is the charge of the proton. Okay. Then charge of nucleus আমরা কিভাবে বের করব? Number of proton, that means atomic number কে you have to multiply by the charge. Okay. Then you can calculate the total charge of the nucleus. ঠিক আছে? Okay. তাহলে আমরা Z টা কি আর E হচ্ছে কি আমার ইলেকট্রনের চার্জ। তাহলে আমরা এখান থেকে লিখতে পারি 1 by 4 pi epsilon naught Z squared by R squared. So we get one expression for Fe. Okay. Now I need another expression for Fc. Okay. So next হচ্ছে কি আমরা another expression we'll find out for Fc. আচ্ছা Fc টা কি বলতো? Fc এর কি ফোর্স বলেছিলাম?
Centrifugal by Rs.
হ্যাঁ? Centrifugal force. Centrifugal force এর equation কি? বলো?
mv square by r.
Yes, that is S equal to a b squared by r. So we get one expression for Fe, we get another expression for Fc. So we can equate these two. Okay, আমরা এক জায়গায় বসাই। We can write from here 1 by 4 pi epsilon naught Z squared by R squared. And this side we can write B squared by R. Okay, we can write. From both sides, here is 1R, here is a square. So this is square and R we can cancel. Okay, so we can write B squared equal to Z squared by 4 pi epsilon naught. Okay, F R. Can I write it? Just changing the side. Yeah. Just side change করে লিখলাম। তাহলে এখন এখানে now we can write B equal to root over Z squared by 4 pi epsilon naught F R. So we get one expression for field, that is velocity of the electron. We get, this is our equation number 1. Later on, we'll use this equation. So in the side note, we can write it. Okay, we'll take a note here. Okay? We can take a note here, and we write down the velocity v equal to u2 bar set v square by 4 pi epsilon naught a I. This is our equation number 1. Okay, now I wrap this one. এখন আমরা নেক্সট স্টেপে চলে যাব। আমরা এখান থেকে বের করলাম কি ভেলোসিটি। আচ্ছা, এখন what is our fourth postulates? আমাদের fourth postulates কি ছিল? বলো, Bohr's atom model. What is our fourth postulate?
MVR is equal to NX divided by 2 pi.
Good. MVR equal to NH by 2 pi. Right? This is we get from our fourth postulate. So from here we can derive one expression for V. So V equal to, we can write, that is AH by 2 pi MR. This is our equation number 2. Equation number 1, V. Equation number 2. So these both are the expression of the velocity. So we can equate, so equation 1 equal to equation number 2. Okay, so equation number 1 again, that is u2 bar set v square divided by 4 pi epsilon naught mr equal to nh by 2 pi mr. Very simple. Now for our better calculation, easy calculation, we can take that square on both the sides. Okay, so for our easy calculation, we can take the square on both the sides. So set v square divided by 4 pi epsilon naught mr is equal to v square h square by 2 pi mr. তাই না? আমরা কিভাবে লিখতে পারি? এখানে কিন্তু আমার দেখো, আমরা বোথ স্কয়ার নিচ্ছি, n স্কয়ার h স্কয়ার, এখানে কিন্তু আমার সবগুলো স্কয়ার হয়ে যায়, 4 pi স্কয়ার n স্কয়ার r স্কয়ার, তাই না? স্কয়ার হয়ে যায়। Now from this part, now we cancel 4 cancel, 4 cancel, pi square cancel, m cancel, square cancel, r cancel, r square cancel. Right now, we will find out the r. So r, there is r. So we can write r equal to, okay, m square, h square, epsilon naught divided by a, say, pi, different pi আছে pi m set k square, তাই না? এখানে আমরা এভাবে লিখতে পারি, তাই না? ওকে, so in general we can write rn equal to rn, that is rn is the any value 1 2 3 4 integer number. Rn equal to, we can write n square h square epsilon naught divided by pi m set k square. This is our radius of the nth orbital electron. Okay, Rn is the, this is the radius of the nth orbital electron. Is that clear? Acha. Now for hydrogen, what is the value of Z? Z value for hydrogen?
1.
1.
Yes. For hydrogen, the value of Z equal to 1. We will not take A equal to 1. Why? Because it can, if the electron can gain energy, it can jump to the higher energy level. So we'll keep it. Okay. So we take Z equal to 1. So in that case, R equal to N square h square epsilon naught pi a e square. This is for the hydrogen. Okay? This is for the hydrogen. Okay, so আমরা r equal to আমরা একটা expression পেলাম. Okay, this is our equation number 3. So r equal to আমরা কি লিখবো এই equationটা you must remember this equation. Okay, r equal to a square h square epsilon 1 divided by pi f z a square z a square. This is our equation number 3. For our mathematical purpose, you must remember this equation because you may get only the math, not the derivation. So in that case, what you do? You have to memorize, okay? The equation. So I love this part. You got this part? Okay. So already we calculate the radius of the orbit. Now next is that I will calculate the energy level. Energy level to calculate with them. Acha. One thing tell me, total energy সমান what we can write total energy equal to what? Total energy. Total energy. Total energy. This is
Kinetic energy and potential energy.
yes, kinetic energy plus potential energy. That is total energy. Then, okay. Now, what is kinetic energy? Kinetic energy should be what is kinetic energy? What is the expression for kinetic energy? There is very small.
Half mv
Half
square.
mv
Right. Kinetic energy half a square. Then, we need one expression for potential energy. Okay? আচ্ছা এখানে একটা জিনিস করতে হবে সেটা হচ্ছে আমাদের সেপারেটলি আমরা একটু কাইনেটিক এনার্জি লিখতেছি কাইনেটিক এনার্জি সেপারেটলি লিখতে কাইনেটিক এনার্জি half a square. Why? Because look at equation number 1. Look at equation number 1. The value v already we calculate from there. So we'll put the value or expression, you can say expression for v here. Okay. So half a v square. So it is z v square divided by 4 pi epsilon naught a r. A and it cancel. So from here we can write z v square by 8 pi epsilon naught r. That is our kinetic energy. Now we need one expression related to potential energy. So potential energy. আচ্ছা এই potential energyটা কিভাবে আসছে আমি তোমরা directly using this one in the exam, no problem. But for your knowing purpose, তোমরা জিনিসটা একটু শিখে রাখো কিভাবে জিনিসটা তুমি ইজিলি মুখস্থ বসাই দিতে পারবা কিন্তু কেন হচ্ছে পটেনশিয়াল এনার্জিটা এটা তোমরা একটু দেখো আচ্ছা দেখো here is a nucleus and this is the orbit. Now if you want to calculate the potential energy, that means you have to calculate the work done for what? That is 1 electron is an infinity. 1 electron in infinity. From infinity, you have to bring it in the orbit. Okay? For infinity, you have to bring it in the orbit. This is the radius. This is the radius. So, how much work you have to do to bring the electron from the infinity to this radius, this orbit? That is the work done, and this is your potential energy. Is that clear? Now, potential energy, or you can say the work done is equal to W equal to F into S. Now, F, force. Here, force is the electrostatic force. Already we calculated the electrostatic force. We know that is 1 by 4 pi epsilon naught Z A square by R square. This is our electrostatic force. Now, what is S? এখন দেখো, from infinity to this orbit, we are bringing the electron. Okay, you want to calculate the distance. S is the distance, isn't it? So what we do, we make it small part of the distance. Small part, that is dr. So if you want to calculate the total distance, what we do, আমরা কি করি বলতো?
Integration.
Good, very good. We take the integration. Yes, integration from infinity to r into dr. তাই না? দেখো এই বক্স, এটা হচ্ছে আমার হচ্ছে s, এটা হচ্ছে আমার s। এইখান থেকে এই ইকুয়েশন থেকে সবকিছু পুরো কনস্ট্যান্ট, এক্সেপ্ট সবকিছু কনস্ট্যান্ট এক্সেপ্ট হচ্ছে আমার 1 বাই r স্কয়ার। তাহলে আমার 1 বাই r স্কয়ার কি যদি আমি ইন্টিগ্রেশন করি, তাহলে সেটা কি আসবে বলতো?
-1/r।
Yes, minus 1 by r. তাহলে আমার এখানে হবে হচ্ছে s equal to এই 8টা চলে যাবে, 8টা আমি ইন্টিগ্রেশন নিয়ে আসছি, এখানে মাইনাস, এই মাইনাসটা আমি সামনে দিয়ে দিচ্ছি 1 by r, তাই না? তাহলে আমরা একটু ফ্রেশ করে লিখি, আমি পটেনশিয়াল এনার্জিটা তাহলে কি পাচ্ছি? আমার পটেনশিয়াল এনার্জিটা দ্যাট ইজ PE equal to, we can write minus Z E square by 4 pi epsilon naught by r. এটা হচ্ছে আমার পটেনশিয়াল এনার্জি, তাই না? এখন আমি এই ভ্যালুটা আর এই যে কাইনেটিক এনার্জি ভ্যালুটা আমি এইখানে বসাবো। ওকে, তাহলে আমি এখানে বসাই, আমার টোটাল এনার্জি সমান কি হচ্ছে Z E square by 8 pi epsilon naught r, then potential energy is minus Z E square by 4 pi epsilon naught r. Next হচ্ছে আমাদের S হবে, তাহলে আমরা যদি আমরা লিখতে পারি 8 pi epsilon naught r, পরে এখানে ছোট দিকে, তার মানে হচ্ছে আমরা পাবো মাইনাস Z E square, তাই না? মাইনাস Z E square, ঠিক আছে? তাহলে আমরা টোটাল এনার্জি সমান আমরা কি পাচ্ছি? মাইনাস Z E square by 8 pi epsilon naught r, ঠিক আছে? ওকে, এখন তোমরা দেখো ইকুয়েশন নাম্বার 4, ইকুয়েশন নাম্বার আমরা তাহলে এনার্জি সমান বের করলাম কি? আমরা তাহলে টোটাল এনার্জি সমান বের করলাম Z E square 8 pi epsilon naught r. এখন আমার ইকুয়েশন নাম্বার 3, it's not 4, it is 3. See, we find out one expression for r. Now our next step is that we put the value of r in this equation. So if we put value of r in this equation, so in that case we can write EF equal to minus Z E square divided by 8 pi epsilon naught. আমাদের তাহলে কি করতে হবে? এই যে r, r ভ্যালু আমরা এইখান থেকে from this equation number 3 we will put it here. তাহলে আমরা কি পাই? 8 square epsilon naught divided by pi m Z E square, তাই না? এখন দেখো নেক্সট pi and pi cancel. So pi and pi cancel, nothing else. Okay. So finally we can write minus the z এটা উপরে চলে যাবে তাহলে z squared to the power 4 divided by 8 epsilon naught, so epsilon naught squared n squared h squared. So this is our energy level in.
ম্যাম উপরে z স্কয়ার n e টু দি পাওয়ার 4 হবে না?
Yes. এই m টা কমন করে চলে যাবে। m তো এখানে থাকবে, m তো ক্যান্সেল হয় না। শুধু পাই ক্যান্সেল। গুড, ভেরি গুড। আমার m টা উপরে চলে আসবে। m তাহলে আমি n সমান লিখতে পারি মাইনাস m z স্কয়ার টু দি পাওয়ার 4 divided by 8 is epsilon naught square n square h square. So we get another expression. For the energy level, right? Get another expression for the energy level. So far we calculate two expression. One is for the radius of the orbit, another is for the energy level. Now আমরা consider করছি যে একটা electron. Now we are considering one electron jump from higher energy level to lower energy level. The higher energy level হচ্ছে n থেকে jump করছে n1. ঠিক আছে, তাহলে তার কতটুকু এনার্জি বের হবে? তাহলে del E equal to ওকে En2 minus En1. এখন এই এক্সপ্রেশনটা ইউজ করে এখানে ইকুয়েশনটা বসাবো। জাস্ট ইউজিং দিস এক্সপ্রেশন হিয়ার আমরা কি লিখতে পারি? আমরা তাহলে এখানে লিখতে পারি মাইনাস a z squared equal to 4 divided by 8 epsilon naught squared. n এর জায়গায় কি লিখবো? What we can write? n এর জায়গায়
n2
yes a squared h squared minus plus a z squared equal to 4 divided by 8 epsilon naught squared n1 squared h squared. So now we can take common from here. We can take common. So a z squared equal to 8 epsilon naught squared h squared, all are common. So inside we can write 1 by n1 squared minus 1 by square. That's all. It is just simply if you jump from higher energy level to lower, then how much energy is radiated. Okay. So that's all. This is the end of our first class. So our second class will start from 11. Okay, just after 1 hour. So you all will join. Okay. Okay. Allah Hafiz.
Salam.